Alright, so I have 3 to the power of x plus 9 to the power of x is equal to 27 to the power of x. So to solve this, I'm going to first rewrite 9 here as 3 to the power of 2. So now I have 3 to the power of x plus 3 squared to the power of x is equal to 27. I'm going to rewrite as 3 to the power of 3. So equal to 3 to the power of 3 to the power of x. Now I can actually switch the places of these two as well as these two. So now I'm going to have 3 to the power of x plus 3 to the power of x squared is equal to 3 to the power of x to the power of 3. Now if I let 3 to the power of x equal to the variable t, I'll have t plus t squared is equal to t to the power of 3. So now if I rewrite this, I can have t to the power of 3 minus t squared minus t is equal to 0. So now if I factor out t from this, I get t times t squared minus t minus 1 is equal to 0. So now this gives me two equations. I have t equals 0, which is already a solution, and I have t squared minus t minus 1 is equal to 0. So to solve t squared minus t minus 1 equals 0, all I have to do is plug this into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So I have t is equal to negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 1, times c, which is negative 1. And I have all of this over 2a, so 2 times 1. So now this simplifies to 1 plus or minus the square root of 1 plus 4 over 2, which simplifies to 1 plus or minus the square root of 5 over 2. So remember how we said that t is equal to 3 to the power of x. So let's first start with our first solution of t, which is t equals 0. So if t equals 0 and 3 to the power of x is equal to t, then that means 3 to the power of x equals 0. And this is actually incorrect because you can't take the power of a number and make it equal to 0. So this has no solution of x. So now we come over here to two solutions of x. We have 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. So if 3 to the power of x is equal to 1 plus the square root of 5 over 2, to solve this, I'm going to first take the ln on both sides. So I have ln 3 to the power of x is equal to ln 1 plus the square root of 5 over 2. And now I can move this to the front, so now I have x times ln 3 is equal to ln 1 plus the square root of 5 over 2. Now if I divide both sides by ln 3, these two cancel out, and I'll be left with x is equal to ln 1 plus the square root of 5 over 2 over ln 3. And this is actually 1 plus or minus because the same goes for 1 minus the square root of 5 over 2. So these are my two solutions. Alright, so in this problem, I have 3 to the power of x plus x equals 30. So the first thing I'm going to do is I'm going to subtract x on both sides. So now I have 3 to the power of x is equal to 30 minus x. Now I'm going to go ahead and divide both sides by 3 to the power of x. So now I have 1 is equal to 30 minus x over 3 to the power of x. Now I can also rewrite this as 30 minus x times 3 to the power of negative x. So now I'm going to go ahead and multiply both sides by 3 to the power of 30. So now I have 3 to the power of 30 is equal to 30 minus x times 3 to the power of negative x times 3 to the power of 30. That's going to equal 3 to the power of 30 minus x, because these two exponents simply just add with each other. Now I'm going to take e to the power of ln. So I'm going to multiply I'm going to write this as 30 minus x times e to the power of ln 3 times 30 minus x, because e and ln cancel out, so everything over here simply stays the same. So now I have 30 minus x times ln 3 times e to the power of 30 minus x times ln 3 is equal to 3 to the power of 30 times ln 3. I multiply both sides by ln 3. Now this can be written as 30 minus x times ln 3 is equal to the W Lambert function of 3 to the power of 30 times ln 3. And what the W Lambert function is if I take the W Lambert function of something in the form a to the power of a times e to the power of a, this is simply equal to a. So as you can see here, I'm taking the W Lambert function of 3 to the power of 30 times ln 3. However, this isn't the form a times e to the power of a yet, so I'm going to have to change this and make it into that form. So to do that, I'm going to change this to 30 minus x times ln 3 is equal to the W Lambert function of 27 ln 3 times 3 to the power of 27. So I simply just took off 3 to the power of 3 from 3 to the power of 27. Now I can write this as 30 minus x times ln 3 is equal to the W Lambert function of 27 times ln 3 times e to the power of ln 3. And now I can simplify this to 30 minus x is equal to 27, because the W Lambert function is in the right form, so I simply this is equal to 3. So now I have a simple equation. All I have to do is subtract 30 on both sides. So I get negative x is equal to negative 3, meaning x is equal to 3. So this is my answer. Alright, so I have x to the power of 4 minus 9 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 as x to the power of 2 times 2. So I have x to the power of 2 times 2 minus 9 I'm going to rewrite as 3 squared, which is equal to 0. Now, if I have something in the form a to the power of m times n, this is simply equal to a to the power of m to the power of n. So x to the power of 2 times 2 I can rewrite as x to the power of 2 to the power of 2. I have this minus 3 squared, which is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x squared and b is equal to 3. So I have x squared plus 3 times x squared minus 3 is equal to 0. So now this is going to give me two equations. I'm going to have x squared plus 3 is equal to 0, and I'm going to have x squared minus 3 is equal to 0. So for x squared plus 3 equals 0, all I have to do is simply subtract 3 on both sides. So then these two cancel out, and I'll have x squared is equal to negative 3. So now to solve x squared equals negative 3, I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 3. Now the square root of x squared, that's simply equal to x, and the square root of negative 3 I can rewrite as the square root of 3 times the square root of negative 1. So if you guys already didn't know, the square root of negative 1, this is equal to the imaginary number I. So now I have x is equal to the positive or negative, by the way, this is positive or negative, the square root of 3i. So these are two solutions of x. So now for x squared minus 3 equals 0, all I have to do is add 3 on both sides. So now I have x squared is equal to 3. Now if I take the square root on both sides, I have x is equal to positive or negative square root of 3. So these are my 4 solutions to this problem.
Hey guys, welcome back to Click Academics.
In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 5 to the power of 100 minus 5 to the power of 99. And what we're first going to do is we're going to expand this a little bit. Why don't we change the 5 to the power of 100 into 5 to the power of 99 plus 1. All we're doing is changing this exponent 100 into 99 plus 1, which is all completely legal. And we're still subtracting this with 5 to the power of 99. We're not changing anything with that. All right, so now that we have this, we're going to use an important property of exponents. Let's say we have a to the power of m plus n. A property of exponents, an important property of exponents, states that this is also written as a to the power of m times a to the power of n. Because remember, when we're multiplying exponents with the same bases, we add the exponents together and keep the base. And we're essentially reversing this when we're using this. So let's convert 5 to the power of 99 plus 1 into 5 to the power of 99 times 5 to the power of 1. And we're still subtracting this with 5 to the power of 99. All right, so now that we have this, what we're going to do is, because we have two 5 to the power of 99s, why don't we factor that out? We're going to factor out 5 to the power of 99. So we're going to do 5 to the power of 99 times 5 to the power of 99 times 5 to the power of 1 divided by 5 to the power of 99 is simply just 5 to the power of 1 minus 5 to the power of 99 divided by 5 to the power of 99 is simply 1. Now, 5 to the power of 1 is just 5, so this is essentially asking 5 minus 1, which is 4. So we have 4 times 5 to the power of 99. And this is actually the most we can simplify it with a human, because to find the exact answer of this, I mean, not even an actual calculator could do that. We would have to use a scientific calculator. So this is the most exact answer we can do.